children, welcome back. The chapter is real numbers for standard 10 and it's part 4. So in this segment we will prove root 2 is irrational and related problems. So before we go into that, let us recap what is a rational number and an irrational number. So you learned it in 9th standard. Rational number is a number which can be expressed in the form of p by q, where p and q are integers and q not equal to 0. Now, there are two types in rational numbers. One is terminating and another is non-terminating. So when you divide the number, you will get 1 by 2 is equal to 0.5, 7 by 4 is 1.75, 4 by 5 equal to 0.8. So it is terminating. After 1 or 2 or 3 or 4 decimals, it will terminate. They are called terminating decimals. And another type is non-terminating but recurring decimals. For example, 4 by 11 if you divide, 36 will get continuously, it will get repeated. So you can write this as 0.36. On the top of 36 you can put a bar. That means 36 is getting repeated continuously. 11 by 6 it is 1.8333. So you will put a bar on the top of 3. So these are also rational numbers. You have learned last year when a number like this is given, this or this is given, how to convert it into fractions also you have learned in your previous class, previous standard. So these are these type of numbers, terminating and one is terminating and the other is non-terminating but recurring decimals are called rational numbers. Now comes the irrational numbers. Irrational numbers are non-repeating and non-terminating decimals. So in rational number you had terminating one type and non-terminating but recurring. But here it is non-repeating and non-terminating. So that means, for example, 0.02002, 0002, etc. Here it is continuously going and there is no pattern. The earlier this one, it was like 0.63, 63, 63 was, the 63 was getting repeated, recurring. But here 2, 0, 0, then again 2, then another 3 zeros are there. So these type of numbers are irrational numbers. All roots, root 2, root 3, root 5, root 6, these are also irrational numbers. Pi is a number. Pi is also irrational. The number is 3.1415926535 etc. It keeps on going. So there is no pattern in this. So this is an example of pi. But during calculation we take pi equal to 22 by 7. Because 22 by 7 if you divide, it is also 3.130, 3.14. So here also it is 3.14 and then continue. So for calculation purpose, wherever pi is there, we generally take 22 by 7. So 22 by 7 is a rational number, but whereas pi is a rational number. Now we will prove root 2 is irrational. So for this we are going to use a different method, theory of contradiction. So what we have to prove root 2 is irrational. Before that, okay, let us finish up this. So for that let us take root 2 as a rational number. We have to prove it is irrational, but we will assume that root 2 is rational. So if it is a rational number, you can write it in the form of p by q, where p and q are positive integers and p and q are co-primes. Co-primes means p and q has a common factor 1. They are called co-primes. You can note it down. Co-prime numbers are numbers which have their common factor as 1. And q not equal to 0. So when you write in your exam, you have to write p and q are co-primes, q not equal to 0. This thing you have to definitely write. Then now squaring on both sides, you will get root 2 the whole square is equal to p squared by q squared. So root 2 the whole square means root 2 into root 2 is 2 equal to p squared by q squared. So cross multiply 2q squared is p squared equal to 2q squared. So name it as A. Now p squared has 2 as a factor. So p also has 2 as a factor. So equation 1. Now since p has 2 as factor, you can write p equal to 2c. Let p equal to 2c for any positive integer c. Now substituting this p equal to 2c in this equation, p squared equal to 2q squared, in this equation A, we will substitute. So p square, so 2c the whole square equal to 2q squared, 4c squared equal to 2q squared, therefore q squared equal to 2c squared. So you get q squared has 2 as a factor here also, so q also has 2 as factor. So now p has 2 as factor, here p has 2 as factor. And q also has 2 as factor. Hope it's clear till now. Shall I continue? Okay. So from 1 and 2, from equation 1 and 2, p and q has 2 as factor. But we have assumed that p and q are co-primes. So that means it should have only 1 as a factor, but here, whereas here we are having p and q has 2 as factor, which is contradicting to our assumption p and q are co-primes. So therefore our assumption is wrong. Therefore root 2 is irrational. Okay, now we will prove one more. Prove that root 5 is irrational. So any number is given is the same method. So let us assume root 5 is rational. So you can write it as p by q, where p and q are positive integers and they are co-primes, and q not equal to 0. Squaring on both sides, you will get 5 is equal to p squared by q squared. Cross multiply p squared equal to 5q squared. That is equation 1. So that means p squared has 5 as a factor, or p has 5 as p squared has 5 as factor, or you can even write p squared is divisible by 5. Anything is fine. Therefore p has 5 as factor, or p is divisible by 5. Hope it's clear. Now p has 5 as factor, so we will write let p equal to 5c, where c is any positive integer. So substitute this in this equation 1. So you can write in the place of p it is 5c. So 5c the whole square will become 25c square equal to 5q square. You are going to substitute in this equation. From this you will get q squared equal to 5c square. That means q squared is having 5 as a factor. Therefore q also has 5 as a factor. So from equation 2 and 4, you will get p and q has 5 as a factor, which is contradicting to our assumption that p and q are co-primes. Therefore our assumption is wrong. Therefore root 5 is irrational. So please practice this, because these questions very often comes in your exam. Now in your 9th standard portion, you have learned rational plus irrational, or rational minus irrational, rational multiplied by an irrational, and rational divided by an irrational, or irrational divided by a rational is always irrational. This property you learned. Now we are going to prove these properties too. Okay, prove that root 2 plus root 5 is irrational. So here both are irrational numbers only, but here it happens it is actually irrational only. So we are going to prove this. For this, again the same way we did for that root 2 root 5 rational, the same way we will assume that it is rational. So if it is rational, it is equal to p by q, where p and q are positive integers and q not equal to 0. So now we will bring root, we will keep one of the root on one side and then take the other root to the other side. Root 5 is equal to, or root 2 is equal to, anything you can do. Now you will square it on both sides. So root 5 the whole square will become 5, and p by q root 5 the whole square equal to p by q minus root 2 the whole square. So you will get p squared by q squared plus 2 minus 2p by q root 2. A minus b the whole squared, a squared plus b squared minus 2ab. Bring this to this side. So 5 minus 2 is 3. This also to this side. So p squared by q squared equal to this term, and then take the LCM here, 3q square minus p squared by q squared here. Then cross multiply, because you have to keep only this root 2 on one side. Only this root 2 you have to keep it on one side. So you have to bring all the others. So before cross multiplying, you have to take 3q squared minus p squared by q squared. And then see, it will be like this. 3q square minus p squared by q squared is equal to minus 2p by q root 2. Now you will cross multiply this. This you will take it here and this you will bring it here. So it will become 3q squared minus p squared into q by minus 2p. You will cross multiply, you will get this. So simplify this. Q and q will get one q, and here 1q will get cancelled. So and this minus 2, when you are multiplying, you will get p squared minus 3q squared by 2pq. Now you will write RHS is rational since p and q are positive. Since p and q are positive integers. But we know root 2 is irrational. So these type of questions, if it is a 3-mark question, then you have to prove root 2 is irrational. If it is a 3-mark question, you have to prove. If it is a 2-mark question, you can simply say we know that root 2 is irrational, but from our calculation we got RHS is, right hand side is rational, but LHS is irrational. That means LHS not equal to RHS. Therefore, our assumption is wrong. Therefore, root 2 plus root 5 is irrational. So, these type of questions are also very sure questions in your exams. Prove 3 root 2 is irrational. So, 3 is a rational number and root 2 is irrational number. So, rational into irrational is always irrational. So again we will assume that it is rational. So you will write it as a by b, where a and b are integers and b not equal to 0. Bring the 3 to the denominator on the opposite side. So a by 3b. Now you will write RHS is, this side is rational because a and b are integers. LHS, we know root 2 is irrational. So LHS not equal to RHS. Therefore our assumption is wrong. 3 root 2 is irrational. You will write only these steps. Don't write too many steps and make it complicated. And you will lose your time also and it will look very messy. Now we will prove 5 minus root 3 is irrational. Again 5 is rational number, root 3 is irrational number. So 5 minus rational minus irrational is always irrational. So again we will assume it is a rational. So it is p by q. 5 minus root 3 equal to p by q. Now bring minus root 3 here. So it will become root 3 and 5 minus p by q. Then take the LCM, 5q minus p by q. Again RHS is rational since p and q are integers. LHS, we know root 3 is irrational. LHS not equal to RHS. Therefore, our assumption is wrong. 5 minus root 3 is irrational. So, these are the main portions that you have. We have covered all the topics of this chapter. So, I will come up with some different type of questions as and when I get questions from different varieties. So till then, keep practicing these 4 parts. So all varieties have been covered here. So see you soon. Have a nice day.